Welcome to the part 2 of a review of Jamb 2025 questions that have been written so far. So these are the parts of the question that have occurred in this year 2025. And if you're writing this Jamb this year for your admission, you are very lucky because for what I've seen so far, the questions are quite very much easy. It's just left for you to calm down and apply the formulas you've been taught. Sincerely, I was amazed when I was shocked when I saw the questions. So some of my students sent some of these to me. They were not able to capture the options for some of them, but nevertheless, I am here to let us have a review of the questions and then other concepts that may be surrounding each of the questions. All right, let's dive in. The first one says, the gravitational pull between two bodies is 20 Newton. Find the gravitational pull when their distance of separation is doubled. All right, we have the pull at 20. Distance is doubled. What is going to be? Let's recall that the gravitational pull F is proportional to the square of the distance apart. So introducing a constant, we have that F is equals to K over R squared. That means that F R squared is equals to a constant. So F1 R1 squared is equals to F2 R2 squared. So the first force here is 20. So 20 times R1 squared is equals to, final force is unknown, F2 times, now R2 is double of R1, so that is, we'll take away this and put 2 times R1 all squared. So doing this, we are going to have it to be that 20 R1 squared is equals to F2. 2 squared is 4. R1 squared is R1 squared. And of course, this one, we cancel this one here. We are left with 20 equals 4F2. Divide both sides by 4. So F2 is equals to 5 Newton, which is option D. Now, the concept you can use this to solve, other concept you can use them as for concept like Boyle's law, Charles' law, that is with laws. Just put down the laws, make sure you have your constant on one side, then equate the first conditions to second conditions. Doing that, you always find your way out. Let's continue. Second one says, a man pushes a box with a force of 50 Newton across a floor with no friction. If the box moves 4 meters, calculate the work done. Now the work done by a force is given as work equals to force times distance moved. And of course, since there's no friction, so this will go. So our force is 50. So that's equal to 50 times distance moved is 4 meters. That is 5 times 4 is 20. Then add this 0, that is 200 joules of work. Option B. The next says, which of the following is not a property of sound? All right, we know that sound is an example of a longitudinal wave, because it travels in the same direction with its vibration. So travel direction is parallel to vibration direction. And among the options given, reflection is sound undergoes this. It also refracts. There's also interference, but there's no polarization. Sound wave cannot be plane polarized. It's only attributed to light waves. Let's continue. Number 4 says, the energy stored in a capacitor is given by dash. Now, what does a capacitor do? Capacitor job is to store charges, across two oppositely charged plates. And to know how good a capacitor is, talk about the capacitance, which is the measure of charge per PD. So capacitance C is given as charge per potential difference V. And energy stored in a capacitor is given by energy E equals to 1 over 2 QV. But from this place, we know that from here, Q is equal to CV. So we can say that energy is equal to 1 over 2 Q times, instead of putting this, sorry, Q is, take away this Q and put a CV times CV, that's another V here, that will give us 1 over 2 CV squared. Again, we know that V here is, from here, V is equal to Q over C. So we can take away V here and put Q over C. So have energy is equal to 1 over 2 Q times Q again over C. That is 1 over 2 Q squared over C. So in a nutshell, energy stored in a capacitor or the work done is given as energy E equals to 1 over 2 QV or 1 over 2 CV squared or 1 over 2 Q squared all over C. And don't forget, for capacitors in parallel, total capacitance is given as CT equals to C1 plus C2 plus C3 and so on. And if they are series, we use the inverse formula, 1 over CT equals 1 over C1 plus 1 over C2 plus 1 over C3. And if they are in series and they are just two capacitors, there's a shortcut we can use. We can use product over sum. Product over sum. For example, if we have two capacitors, just C1, C2. C1, C2, this way. C6 total is given by product C1, C2 over sum C1 plus C2. This is a shortcut. All right, let's write down. The last one says, what is the function of a transformer? All right, a transformer's job is to take the voltage of the power source and alter it. Altering it now, it can step it up or step it down based on what is required. So in a nutshell, we have the primary source on the primary coil P, then we now have secondary coil S. So the function of a transformer is to step up or step down a voltage of a system. And to do that, we have some formulas we can always use to solve for transformers. So just as a quick reminder, let's have a review of these formulas. If we have number of turns N, we have voltage V, and we have a current I. Now, the quick review is that if we have solving for N and V, know that N, V, N, V. So primary, secondary, secondary, primary. That is for N and V. But if you are solving between I and V, primary, primary, secondary, secondary. And if you are solving between I and N, the same way. Primary, primary, secondary, secondary. If you're able to remember this, we don't have any issue with transformers. And then don't forget, for transformer, the efficiency is given by power output over power input times 100 over 1. The power output is power in the second, that is power in the secondary, which is I in in secondary times V in secondary all over I in primary times V in primary times 100 over 1. Now the next question says, in an echo experiment, the sound takes 2 seconds to return. If the speed of the sound is 340 meters per second, what is the distance from the wall? Okay, an echo is a reflection of sound wave from a hard surface. For example, if you are in an empty room, when you shout, oh, you can see yourself, you can see that sound coming back to you. That means the sound has been reflected. So let's dive in. So let's assume we have a wall. If you have a wall this way, and the person makes the sound to go like this here to here is distance x. To come back again on that distance x. So total distance traveled is now 2x. So speed of sound v is equals to total distance covered x plus x 2x over total time taken over t. So in this case now we have speed as 340 is equals to 2x. Our t is 2 seconds. Yes, 2 seconds. So 2 cancels t. And of course, x becomes equal to what? 340 meters. That's option A. Now, this phenomenon is used in research or in oil and gas exploration, whereby some sound wave is sent down the sea to the bottom of the sea, and the kind of echo and the time taken to hear about the echo will reveal the kind of mineral that is inside the bedrock. Let's continue. Number 7 says, the instrument used to measure electric current is dash. The answer here is ammeter. Ammeter. Ammeter is used to measure current. However, you have other instruments like the voltmeter. We have voltmeter. We have a galvanometer. Galvanometer. I also have ohmmeter. We also have multimeter. Now, voltmeter is used to measure potential difference or the voltage. While galvanometer, which is also known as milliammeter, is used to measure small amount of electric current. Yes. Now, this one is ohmmeter for the measurement of electrical resistance. And a multi means many. So multimeter is a device which can function as any of these, which has the function of this combined. And we can always convert galvanometers to voltmeter or to ammeter using what we call shunts and multipliers. The videos are in our channel. You can check out that conversion of ammeters and galvanometers and so using what shunts and multipliers. Let's continue. Number 8 says the unit of electric power is dash. The answer is watts. Watts is named after a scientist called James Watts. James Watts. James Watts is recognized as the man who invented the steam engine, and since then the unit of power has been used to honor him by naming this unit of SI unit of power to be watts. However, there are other units of watts which are not SI. Units like we have horsepower HP. Horsepower HP. Of course, 1 horsepower is equivalent to, I think, 734 watts. But watts is used as the SI unit of electric power. Let's continue. Number 9 says, What happens to the pressure of a gas if the volume is halved at constant temperature? Now let's review a Boyle's law. Boyle's law says that volume is proportional to the inverse of pressure. So V is equals to K over P. That means that P1 V1 equals P2 V2. So what happens to the pressure if the volume is halved? So if volume is halved, that means V2 is equals to V1 over 2. So let's find out what happens. So in that case, P1 times V1 equals, now P2 times having V, now V2 now is V1 over 2. So V1 over 2. So we're looking for the pressure P2. How do we get pressure now P2? Now we have that P1 V1 over 1 is equals to P2 V1 over 2. V1 cancels V1 here, so P2 is equals to 2 P1. So in that case, if the volume is halved, then pressure is doubled. Because P2 now is the double of P1. And lastly, we have in that last question of number 10, what is the resistance of a wire that allows 2 amperes of current when 10 volt is applied? So let's recall Ohm's law. Ohm's law says that V is equals to IR. So here we have current I is 2 amperes, while V is 10 volts. So we put it into this, our V is 10, our I is 2, our R is unknown. So 10 equals to R. So divide both sides by 2. 2 here is 2, 2 here cancel 2, 2 here 1, 2 here is 5. So our resistance is equals to 5 ohms. All right, don't forget to like and subscribe to this channel, or if you're working on following us from Facebook, don't forget to follow us there so that if you kept abreast with anytime we upload our videos and systems. Our aim is to eradicate exam phobia in Nigeria and be able to step up the academic standard of the country, so we should be able to measure up with some other countries who are doing pretty well. Until then, see you in our next video. Thank you.